All right, we're going to get started soon. In the meantime, I'm going to introduce our next speaker. We are going to hear from Chen, who is the Director of AI Engineering at Cambia Health Solutions. He builds AI applications from prototype to production in healthcare, and this talk is going to cover Cambia's journey of building a chatbot from scratch to help their health plan customers. Great. Who in the room has built a chatbot or is currently using one? Great. And who is here is interested in building a chatbot? I should see every hand up. Every hand up. All right. Awesome. OK, we're going to get started shortly. It is 12:05, so if you want to get started, go right ahead. Let's give it up for Chen.
OK, I think right now it's good afternoon, past 12. So my name is Chen. So I lead the data science and AI team at the Cambia Health Solutions. So I think we asked the question, who have used a conversational AI interface, which is AKA chatbot, right? And there are so many consumer-facing devices over there, Google Home, Alexa, Siri, Microsoft, Cortana, and every of them. Personally, I'm using a Google Home at my home. I use it to set up my kitchen timers, kids' TV timers, so that they can only watch 10 minutes TV, and my kids are using that one to play TVs in my via Chromecast. So I think like 50% of people raise their hand they want to build a chatbot, right? But as a consumer of the healthcare, I don't know how many of you have used really a conversational AI or chatbot for your healthcare need. So for me, I think I probably am the most likely, maybe among the first batch of users. So because I need to test the chatbot when I build it. So why we're using it? Why we're using a chatbot? Because it's so simple, it's so convenient, right? For anything I know the chatbot can do, I can just say it. So OK Google, just play Peppa Pig on my on my Chromecast. So it's done, right? So can we bring the convenience into the healthcare? I think the answer is yes. So today I'm going to share what we have done. This one. So this is the agenda. So building a machine, building a chatbot means a lot. You can really think about it. A chatbot itself is really a production AI system. So it means you need to build machine learning models. It means you need to have DevOps. You need to have the machine learning pipeline so that you can continuously refresh your machine learning model. It means you will need to have some type of data pipeline because your data from the previous talk in this room, your data is not necessarily available when you need it. It might be in some, in your Hadoop. You might need to build an API to support it. And in the same time, a chatbot might need to use multiple service. You might need to have a microservice framework. So it means a lot, right? So today we are going to really, since it's really an AI for healthcare conference. So today we are mainly focused on two things: really about the machine learning model, and then how we get the data to train the machine learning model. So this is a brief introduction of Cambia Health Solutions. So Cambia Health Solutions is a parent company of a bunch of other companies. One of them is the Regions, which is a member of Blue Cross Blue Shield Association operating in Oregon, Washington, Utah, and Idaho. So we also have a bunch of other companies. So Cambia has about 2.6 million members. We have about 5,000 employees. So Cambia's the root is really rooted from an idea in I think it's 1917. So when those timber workers in Pacific Northwest started to put their money for unplanned injury or sickness. So they actually become they are the first consumers of the health plan, and also they created the first employer-based health plan in US. So Cambia currently owns a bunch of other smaller companies. One of them are MedSavvy, and the other one is really about HealthSpark. So they are the company who are providing transparency to your healthcare, regarding your treatment cost, regarding your grade of your drug or medicines. So Cambia's cause is to serve as a catalyst to transform healthcare, creating a person-focused and economical sustainable system. So then we'll talk about why do we need conversational interface in healthcare. So there's a reason why we started. Always start with why. Why is really AI is a new gig for in healthcare, or actually it was not maybe back in 3 years. Healthcare is complicated, right? So consumer is confused. Even I worked for a healthcare company for 3 years. I still sometimes I don't know what to do when my kids are sick. So consumer needs help, and and actually more interestingly, our customer service representative requires so many screens when they answer a question. Oh, my kid is sick. What should I do? So they will need to put like 5 or maybe into 10 screens to say, oh, whether you are in network or out of network, those type of things. So, and really the trend is that a lot of questions can be answered automatically and easily. So that provides another opportunity of the robotic process automation, RPA, with AI. So, our approach is we intended to use AI as augmented intelligence. So we want to build AI assistive bot first. So we build a bot. We start building a bot for our customer service representative instead of directly rolling it out to our consumer directly. Then with some success, so we expand to our consumer. So we have a consumer-facing bot. So what have we built? So in about a year and a half, we built a chatbot platform very similar to the how Alexa is organized. So it's really HIPAA compliant. I think here in healthcare, everyone knows what HIPAA means. So we have the pluggable scales. It means we can build multiple scales in the same time. So a scale means really, you look at the list of scales here. So basically, scales is really about different type of things you can do with your chatbot. So and it's knowledgeable. So we build a knowledge graph to model some type of the kind of like healthcare domain specific knowledge. For example, specialty mapping, how to map a layman's term to a healthcare specialty, because your internal system doesn't understand a food doctor. But for me, I always say, oh, my food is painful, I need a doctor. Right? I won't say I need to find a podiatrist or whatever thing. I just don't know. We also have the configurable personas. So basically, we can combine different type of skills into a specific bot, so that we can face in different type of users. For example, we have a persona for our customer service representative. We have a persona for our health plan consumers, really our health plan members. Cambia also has really consumer-facing app. So we also create one persona for those really non-health plan related chatbot persona. And then we really have the flexible delivery channels. So really, what we build is an API, and then we first rolled out with a web UI. And the second one, really, we started, integrating the chatbot into a mobile application. And then thirdly, we build an Alexa scale for regions. When it as really a testing in use case using exactly the same backend. So the scales really about a few things here. So frequently asked questions. for our health plan members about, okay, how, for example, how do I reset my password? How do I get a replacement ID card? Find doctors. Find doctors is most frequently asked question to our customer service representative. So they will always say, I'm sick, I need to find doctor. Who is in network, who is best, those type of things. So we build such one. So you can ask, okay, can I find a food doctor near Seattle, Washington? I want doctor to be male. Those type of questions. The other one is really, is my doctor in network? This is the second most asked questions to our customer service. It's really about, okay, I know a doctor, for example, John Smith, I live in Seattle. I want to see this. I heard this doctor is good, but I want to see whether it's in network or not, because if it's not, then I need to pay a lot. I don't want to do that. So I always, okay, is Dr. John Smith in Seattle or Washington in network for me? So we might be able to find 10 John Smiths there, and then we can ask we can ask additional questions to narrow it down to a doctor. So then we can tell you whether it's really in network or not. So the other thing is really about a very generic sense, medical terms, healthcare terms. For example, what is HSA? What is deductible? What is my copay? Those type of things, and then really have some benefit question. One frequent question, I want to see my dentist. What's my benefit? And then the other thing we related about the different drugs, drug side effect, drug cost, related stuff. Yeah, so building such things, really the first thing we need to do is really about the models. Since I think when I started talking, about exploring the opportunity here about speaking, I think the question Michael asked me is really about, why if you are building a bot right now, are you going to, build from scratch? Because answer probably is no, because at that time, when we start building it, none of the service from cloud, for example, Amazon, I think Next, Google API.ai, I think right now named called Dialogflow, none of them was HIPAA compliant. We can't use it, right? But really, actually, the data pieces, even right now, the data pieces, I think the main focus about our data was still applicable. So without data, you can't really build a model. Even with our currently, even with Amazon Next, even with Amazon Alexa, you still need to feed them the data so that they will train the model. They will train the model for you, but you still need to have the data. So for us, when we build a model, we need to find the data. So the data is really a typical code start problem. So our approach is like the general guideline is this. So we start with a data set with real examples. I will explain later about what are our real example. And then we use a synthetic data to enhance our training set. And then we use the human annotators to annotate our data to be the source of truth. And then we use the other interesting piece, we use our production log and the feedback from our internal users as part of the training data set enhancement. So this is our the diagram. So there are multiple things inside. One is really about from the top right, the top left. So it's really we used our customer service core history, and then we use that with some filtering and cleaning. So we send it to our human annotator. The second piece is we use context-free grammars. I will give example later in later slide. So we use this grammar to generate synthetic examples. So those two pieces become our initial training data set to train two specific models for our chatbot. So once we have that, so we can have a very first version of our chatbot. So basically, we put the data into we put the model into production, kind of production for a few testing users. So this user will use it, and then we capture the runtime log and also use some type of user feedback. We sample them, we send to our human annotator. So we have this continuous pipeline about getting the data for our models. So real human chat data. So we have about, so in our health plan website, regions.com, we have about, we have a chat functionality. So our health plan members can chat with you via those chat. So in 7 years, I think we have about a total of 500,000 chat conversations. So what we used that data for is we run topic modeling and clustering to find relevant examples. For example, how we want to learn how people are asked questions about finding providers. So that's where the source is. So we learn different patterns so that we can generalize it. And then actually we also, I think earlier in the early slide we have frequent asked questions. So this is also the source of our data to find such question answering pairs. That's why we know it's frequent ask. So actually, we are not the first one doing that. Actually, Airbnb has taken a similar approach when they built their customer service enhancement system. So there's a link over there. And the synthetic example, I think the real world, our real world chat examples are real, are useful, but the challenge is that the amount is not enough. So and the coverage is very limited. We barely find enough examples to make a model work. So I think that our solution is really about building a context-free grammars. So there are examples, So if you look at that, so I think from someone, I think with the linguistic background, I think you can understand it. So it's really about S is a sentence. Sentence is about a verb, about specialty, about location, about member. And then verb can be find or can be locate. Specialty can be food doctor, can be podiatrist. Location can be city, state. So in such patterns, so basically we're creating examples for our machine learning models. So CFG can be, the good thing is really CFG can be reused among different intent. For example, if I create a CFG for our location, so for any place I need location, I can reuse the same CFG. I don't need to recreate it. So it's a quick and dirty to get started. It's really specific to cold start our data for the machine learning model. And the other benefit is no annotation is required. Because when I generate it, I know exactly what I'm generating. It's about the intent and also about the different slot. I will talk about the two models later. So, but the disadvantage, the variety is very limited, and also sometimes is also limiting the performance of our models. Okay. So human annotators. So we have internal data labelers help annotate. I think in the previous talk, people ask about Google allow their 150 employees access the HIPAA data from one of the other health plan, not us. I think really that's why we have an internal data labeler to help them. So basically they are our part-time employees, and they help us to annotate the data. So we, in general, when we're doing annotation, we always use the inter-reader reliability. I think it's called kappa. So we take the majority vote. So basically, we are for their usage, really we annotate two types of data: the real human chat data samples, and also the production logs and user feedbacks. Okay. So this is about the data pieces. So models, actually, the models internally we have about we start with two models, the intent classification and the slot filling. So that's our approaches about building a chatbot. So intent classification is really about is Dr. John Smith in network? So we call this one as an eligibility check. And find a food doctor in Seattle for member 1, 2, 3, 4, 5, 6, 8, 9. So it's a provider search. So it's really about it's a multi-class classification problem. And then slot filling is really about find different slots in a given human input. For example, find a food doctor in Seattle, Washington for this member. So there are a bunch of slots here. We see the food doctor is a specialty, Seattle is a city, Washington is a state, and subscribe ID. That's so we start with those two. Those two are good enough for us to start. Even at the beginning you can even train very simple model when you have a limited number of intents. But later we realize it's not enough. That's why we add a case normalization model, because when our first customer of the chatbot is our customer service representative. we noticed what they used to do is they type everything in uppercase. I don't know why, but they're just doing it. And then, for people who are doing the net NLP, you know that case is a very important indicator for your any NLP model work. So, so that's why we start building very simple model. Actually, this one is not. It's a language. They call it a language model. It's really about. It's not really machine learning model. It's really about we use Wikipedia to train a model to normalize the case first, so that we can have proper cases for our input. So the last one is more about experimental. It's the natural language generation. For example, right? If you say I want to find a food doctor near me, and then you will get a bunch of JSON. It's okay, in your web page, it's okay. Just sure, I can show them a table, I can show them a very nice view or whatever thing. But what if you are in Alexa? You don't want to say city equals whatever. You don't want to do that. So we started doing some type of NLG, but the performance itself is not ideal. So basically, what we end up with really, we're taking a template based. So here is the doctor name is John. First name is John, last name is Smith, city is that. So we take that one. Yeah. So this is actually our modeling sequence. 10 minutes. Okay, I think I have enough. So this is our the sequence of modeling sequence. So you can see that. So when given a user input, it will run through the customization first. After that, we run through the intent classification to say, what type of question you're asking. So we have a dialogue, the part I didn't cover is the dialogue management. It's another story. So we have a dialogue management. So the dialogue management will know, okay, which sequence labeling or the slot filling model I need to send it to. So then it become one-to-n problem. So and then for each sequence labeling, we are trying to extract different slots from the input, so that we can the dialogue management will need to know, do I have enough information to fetch to find a doctor? If not, I will need to ask more questions. If I do, I can simply fetch, call the other APIs, so I can get the response, so I can render the response back to the user. So that's pretty much our journey of building a chatbot. Using the similar approach, we started building personalization. We started building a personalization engine for our other consumer-facing effort. So right now, using that approach, we have built up, the engine to provide recommendations. So maybe this person is due for, to visit eye doctor. So you have eye doctor benefit, you haven't used it. It's near the end. Actually, it's true for all of you. If you haven't done it, you don't forget to utilize the benefit. The dentist, the same thing, right? And also, if someone has a sleep issue, we can recommend to do you want to talk to a care guide for such for a sleep issue? And then also, if we notice someone has some taking some drug which have side effect, we'll also recommend you to see do you want to check this the side effect for your drug, or whether you have a cheaper drug. So that's where we get such information from our the company Cambia owns about the drugs. So yeah, I think the last thing I want to say is really I think building machine learning models has become much easier with all the things like even Google or whatever things have auto ML become reality. But really building a machine learning model is just the first step. To really operationalize a machine learning model and the system is still, I think, still remains hard. I think really, I hope our experience or journey of building and operationalize a chatbot can be helpful for you, for on your journey of AI for healthcare. Thank you.
All right, thank you so much, Lin. We're going to jump right into Q&A. We have about 5-6 minutes. If you can just raise your hand with questions, and we'll make our way around.
Thank you. Thanks for your presentation.
Thank you.
Can you tell a little bit? The example you used was kind of provider finder.
Yeah.
How are you building in? How are you linking the member who's asking the question? Like, I mean, the location if they're asking for somebody in Seattle, for example, but with their benefit design, right? So, how are you linking the member with the product, and which provider is going to be in network for that particular product?
Yeah. So that's why I mentioned the why do we need a data pipeline for a chatbot? So Cambia first, there are two sides of the question. So when the user log in, or for CSP, when you see the member itself, we know your subscriber ID and your member suffix. With such information, we know exactly what type of network you are in, and what we did actually, we built a pipeline to join those two sets of information, our member information and also our provider information. So we use a network. I think in the healthcare they use something called network set to join those two information, so that we know exactly who is in network, who is not in network for this member.
How do you know who's asking the question, right? So is it like an Alexa sort of thing?
So there are two persona for that purpose, right? If for the one is really for our CSP version, so we use a subscriber ID to identify, and for our health plan member facing persona, we know, so you need to log in with your website, username and password, so that we know who you are, right? So.
Great. Any other questions? We'll do one over here, and we'll come back to you.
So is this like a solution you're selling to hospital companies, or what is?
So it's an internal app. It's not really. It's a build internally for our health plan operations. So we have three set of users. One is our health plan customer service, and then the second one is really our health plan members. So, and the third one is really we have a consumer facing application. So that they can also use it. So we're not selling the solution.
So you built this up from ground up.
Yeah.
So and all the speech and everything you've built from the ground up. The speech recognition.
Not the speech. So the speech we were trying to utilize Alexa, so that we don't need to worry about that. Yeah.
The piece. And how many people did it take to develop this chatbot, and how much long?
Martin Horn from my team, who is a senior data scientist, observed that. I think at the beginning, in total about five people. About 5 people took about us, I think 3 or 4 months to get the very first scale into the bot. I think really about 3 or 4 months. So provide search is our first scale. And then later, adding more scales into the system is really the time. It's a part which takes a little bit more time, and actually operationalize it is another story.
Okay. Thank you.
Mm-hmm.
Thank you. We'll have the last question over here, and then we're going to break for lunch.
I think partly it already answered, because I was wanted to ask about the speech, and you mentioned that Alexa is already integrated with Alexa, or it's in the plans.
I think Amazon Alexa was just become HIPAA compliant early this year. We were not part of the. They reached out whether we want to be part of their HIPAA non-partners. We didn't participate. I think right now we are not taking any effort of making that one available. Even we have the non-PKI version available to test. We build one where we can only log in with our username password to test it, but we didn't pursue.
Oh, so far you didn't integrate it with any voice bot?
No, we didn't. Yeah,
It's still a
speech.
chatbot. Okay.
Yeah.
Okay, thanks.
Thank you. This seems like we have a couple minutes, so I want to get to your question here, unless you'd rather. Okay, great.
I wasn't very clear. Like you said, you're not using Alexa. Is that right?
Right now, we made it possible, but we didn't pursue.
Right.
Yeah.
But you're using some other natural language processor.
Yeah. So basically, we built our own natural language processing capabilities.
Right. Oh, okay.
Mm-hmm.
Because I was going to ask you how much it costs, per month if it was on the cloud or something.
Okay.
Yeah. All right.
Yeah.
All right. Thank you so much. Let's give it up for Lin Chen.
Okay. Thank you.
Thank you, Lin. Lunch is starting in just a couple minutes. On your way out, please remember to get on the Brella app, and you can give reviews and feedback there. We really appreciate that. Again, my name is Miriam. I'll be here in the afternoon for Hub 1. We'll see you guys after lunch. Take care.
For natural language processing, we are